Alright, and our essential question for today is, how is solving an equation with variables on both sides different than combining like terms? I picked that for our essential question because a lot of people treat variables on both sides like they would treat combining like terms, and there is a difference. We are still doing inverse operations to get rid of these variables. So, first, we need to simplify each side of the equation if necessary. So just like we've been learning, if you need to distribute, you distribute. If you need to combine like terms on one side of the equation, you combine those like terms. Once you have two sides of the equation that are simplified, so the 3x is simplified and the x plus 8 is simplified, then we can start solving it. When we solve it, we need to move the variable from one side of the equation to the other. It's usually nicer if we keep the variable positive, but you don't have to. And once we get our variables together, then we're back to that two-step equation. We are always going back to that two-step equation you learned how to solve in 6th grade. So we're going to solve for our variable. These first couple examples have what's called algebra tiles. These bars are x's, and each of these little squares represents 1. So here's 3x, and here's 1x plus 1, 2, 3, 4, 5, 6, 7, 8 more. When we're solving these problems, if you think of this like a balance scale, and this equal sign is keeping those two sides of the scale balanced, then if you take something off of a scale, you need to take the same exact thing off of the other side if you're keeping that scale balanced. So I saw an x on one side, I see an x on the other side, I removed an x from both sides, and that equation should still be balanced. So, algebraically, we are removing x from both sides. This x is no longer on this side. There are only 8 units there. When I took an x away from this side, 3x minus 1x is 2x. We have 2 x's on this side, 8 units on this side. If I split these up in half, one of these x's is worth 4 pieces. One of these x's is worth 4 pieces. So I split each side in half. I divided both sides by 2, and I got x equals 4. 1x was 4 pieces. If we're going to check our work, we need to take x equals 4 and plug it back in everywhere we see an x. So one side is 3 times 4. The other side is 4 plus 8. And when I solve this, I should get the same number on both sides. 3 times 4 is 12. 4 plus 8 is 12. Same number on both sides. That equation is balanced when x equals 4. So this is my answer. X equals 4. Okay? This next question, we have 2 x's and 5 negatives, 3 x's and 3 positives. Again, this is like a balance scale where this equal sign is the tipping point of the scale. So I see 2 x's on this side. I'm going to get rid of them, but now the scale is weighted. This side is falling down, so I have to get rid of 2 of these x's. So I have removed 2 x's on both sides of the scale. When I get rid of these 2 x's, there are 5 negatives left. When I get rid of 2 x's on this side, there is still 1 x left, and 3 more units. To get rid of these 3, I can remove them. I don't have 3 over here to remove, so I'm going to put 3 negatives down here. If I'm putting 3 negatives on this side, I have to put 3 negatives on this side. So I have put 3 negatives down. Remember, adding a negative is the same as subtracting. These cancel. Positive 3 and negative 3 cancels. Negative 5 plus 3, there are now 8 negatives there. So that's my answer. This 1x, sorry, it shouldn't be shaded, but this 1x equals 8 negative pieces. And when you plug it in, 2 times negative 8 minus 5 equals 3 times negative 8 plus 3. 2 times negative 8 is negative 16. Negative 16 minus 5 is negative 21. 3 times negative 8 is negative 24. Negative 24 plus 3 is negative 21. So you get the same thing on both sides, which means that equation is balanced. Are there questions so far? On your SOL test, you might see questions that only give you these pictures, or they would give you pictures that have bags and coins or something. But just know that like mystery things are worth X, units are worth 1. Alright, on the back, there are 4 examples up top, 2 for you to try on the bottom. I'm going to go over all of these. On example 3, our first step was to simplify both sides. 4x plus 10 is simplified. You can't add those because this is an x and this one doesn't have an x. If you were to do 4x plus 10, how would you know if that's supposed to be 14 or 14x? Because one has an x and the other one doesn't. But on this side, we need to distribute the 2. 2 times x is 2x. 2 times 3 is positive 6. So 2x plus 6 equals 4x plus 10. Kenny, what do you think I should do next? What do you think I should do next? Melanie, what should I do next? We're going to subtract 2x from both sides. 2x minus 2x is 0, so we have 6 equals 4x minus 2x, which is 2x plus 10. The reason I subtracted 2x was because I needed to get my variables together. I needed my variables to only be on one side of the equation because I'm comfortable solving equations when I only have one variable term to look at. So, the subtracting 2x was because this 2x was positive. Positive 2x minus 2x is 0. 4x minus 2x is 2x. And now when you look at that equation, 6 equals 2x plus 10, that's a 2-step equation that we should all be comfortable solving. Xavier, what should I do next? Subtract 10 on both sides. 6 minus 10 is negative 4. That equals 2x. 10 minus 10 was 0. Canceled. And James, what's my last step? Divide both sides by 2. So x equals negative 2. Are there questions? All right, example 4. Yassine, what should I do first? Okay, so we're going to simplify the right-hand side by distributing negative 3. Negative 3 times n is negative 3n. Negative 3 times positive 4 is negative 12. Jacob, what should I do next? Naveen, what should I do next? Combine like terms. So this other side of the equation is not simplified yet. 5n and negative 3n. When we add those together, 5 plus negative 3 is 2n plus 3. So Lem, what should I do next? add 3 into both sides. We need to get our variables together. 2n plus 3n is 5n. Negative 3 plus 3 is 0. That equals negative 12. Question? It doesn't matter. So either you're going to have 5n on the left-hand side or negative 5n on the right-hand side. But either way, you'll get the same answer in the end. What's my next step? Go ahead, Grace. Subtract 3 from both sides. 5n equals, be careful, this is a negative 12. Negative 12 minus 3 is negative 15. And then, go ahead. Divide both sides by 5. N equals negative 3. Alright, I'm going to skip example 5 for a minute. On example 6, there are variables on both sides. This 3p is simplified. This negative p plus 5 over 3 is also simplified. But I cannot add p to both sides because that p is being trapped by this 3. I would have to add 1/3 p to both sides. Instead of doing that, I'm going to get rid of this 3 by multiplying both sides by 3. 3 times 3p is 9p. And on this side, times 3 and divided by 3 are inverses of each other, so they cancel. And we have negative p plus 5. We have variables on both sides of the equation. Jennifer N., what should I do to get them together? We're going to add 1p to both sides. 9p plus p is 10p equals 5. To get p by itself, this says 10 times p. The opposite of multiplication is division, so we're going to divide both sides by 10. 10 over 10 is 1, so there's 1p. 5 divided by 10 is 5/10. Can I simplify 5/10? What is it? 1/2, 1 over 2. So p equals 1/2. All right, on number 2, I did the small group with some of you last class, not everyone. So I'm going to explain it a little bit now. All of these terms have fractions in it. Fractions are always difficult to work with. So we want to do our best to get rid of any fractions. In order to get rid of fractions, I'm going to look at all of my denominators. A 3, a 5, and a 6. And this technically has a denominator of 1. 3, 5, and 6. What is their least common multiple? 30. The least common multiple of 3, 5, and 6 is 30. I picked 30 because 30 divided by 3 is 10, 30 divided by 5 is 6, 30 divided by 6 is 5. So when I do this multiplication on both sides, all of my denominators will go away. So I'm going to multiply both sides by 30. I'm going to multiply the entire side of both sides by 30. 30 times 2/3. 30 times 2 is 60. 60 divided by 3 is 20. So this is 20x. Don't forget about the 7/5. 30 times 7 is 210. 210 divided by 5. 42. 30 times x, that's another one, even though that's not a fraction, we still multiply. 30 times x is 30x. 30 times 5 is 150. divided by 6 is 25. Make sure you wrote minus. So, since I multiplied every single term on both sides by 30, I have no more fractions. Once I have no more fractions, this problem is not so intimidating. I'm going to get my variables together, so I'm going to subtract 20x from both sides. So I have 42 equals 10x minus 25. Add 25 to both sides. 67 equals 10x. And divide both sides by 10. X equals 67 over 10. And we're going to leave it like that. Don't write 6.7. Just leave it at 67 tenths. Question? So I wanted to get my variables together. This 20x was positive, so the opposite is subtracting 20x. 20x minus 20x is 0. 0 plus 42 is just 42. 30x minus 20x is 10x minus 25. So I subtracted 20 to get rid of the variable on one side and move it to the other side. Just like up here when we added p, it was to get my variables together. When we added 3n, it was to get the variables together. When we subtracted 2x, it was to get the variables together. All right, you guys try example 5, which is like number 2, where we want to get rid of that fraction. And then you try number 1. We want to combine our like terms first.
If there isn't any other fraction in Final's common denominator, what do?
So your least common denominator is just 5, or least common multiple.